So guys, this section is really talking about exponential, it's exponential growth and decay. So remember the thing we did on Friday where we did it in our breakout groups? Okay, exponential growth and exponential decay. And you did this on your graphs, or you noticed this right away. The values were kind of weird. So, you know, of course, we've got to do, this is what the parent function looks like. Okay. And this was the part where you said, you know what, all these numbers, I can tell that they're all going to the right, or they're all going up, or they're all going the other way. So exponential growth is when b is going to be greater than 1. Okay. And the thing is that it's always going to cross, okay, at 0, 1 and go up. Now, we're going to practice. So, for example, if I want to do y is equal to 2 to the x, I'm going to do that in a slightly different color, okay? And I want to show you the values real quick, okay? And what's my favorite number that I always start out with? It's always 0, right? So what is 2 to the 0 power? It's a 1, isn't it? Okay. So see, I'm just going to start at 0, 1 every single time. This is where the climb will differ. If x is 1, what's 2 to the first? That's 2. So in this case, it's this exact line. And then you go from there, and it climbs then exponentially. So this would be 2 to the second, 2 to the third. So see how it climbs really, really quick. 2, 4, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8. Now let's take a look at another one. Let's do 4. Y is equal to 4 to the x. Well, jinkies, that's going to climb even quicker. I still get 4 to the 0 is 1. But then when I do 4 to the first, I jump up to 4. And 4 to the second jumps up to 16, which I don't have room on my graph. But I notice I still cross here, but now my second number, 1, 2, 3, 4, I'm going to climb so much higher. Do you see how all of those are the same? Okay, so if we had to do domain and range, all right, I'm going to get my highlighter. Notice what's happening. So if I were to put whoa, how do I stop this? This looks like it goes on forever, doesn't it? This goes on for, like, there's no stopping. And in fact, there's no stopping here. This is going to continue forever and ever. So guess what? Your domain for all of these, okay, your domain is all reals. All day, every day. Okay? Your domain is going to be all reals. There is no stopping. You are going to continue out both sides. but the range, okay? Now, it's going to get, do you see how I'm not really crossing, I'm not really hitting. This is going to continue, and it is going to get so small, but it's never going to hit 0, but it's going to get really close. So it starts here, and it's going to climb up forever and ever. So my range here is x is greater than 0, not greater than or equal to, but greater than 0. And let me show you how it's not ever going to hit 0. So let's think about, so right away, okay, let's think of this one. All right, I want to get 2 to be 0 or less. I want it to be a negative. So you know what? I'm going to try, wonder if I put x to the negative first. What do I get? 2 to the negative first. What do I get on my calculator? Any guesses? 2 to the negative first, what happens? To the negative first, come on now.
0.5.
0.5, so I go 1/2. Oh, okay. Well, wonder, you know what? I'm gonna try -2. That's gonna give me a negative, right? What's 2 to the -2? Oh, wait.
0.25.
Yes, 1/4. Oh my goodness. And you know what? It just keeps getting smaller and smaller. Whoops, that's a positive. It just keeps getting closer and closer and closer, and will never, I mean, it can go 1/32, it can get even smaller. It's not going to cross 0. Okay, that's why it's x is greater than 0. Okay, this exponential growth is talking about like interest that you make in the bank and stuff. Okay, so making money. Okay, so we'll talk about more about the money aspect tomorrow. Okay, the other way, decay, is just the opposite. Okay, same equation, except b is less than 1 but greater than 0, which means b is going to be a fraction between 1 and 0. Friends, it is the same exact thing, except we go the other way. Do you remember looking at that from Friday?
Yeah.
Oh yeah. So it just goes the opposite way. All right, so let's try 1/2 x. If I plug in a 0, I get 1. That's exactly where I'm at. If I plug in a 1, I get 1/2. There I am right there. If I plug in a 2, I get 1/4. That's right there. So it's coming down. That's the only difference. So if that, we call this, that piece, the growth factor. So if this piece in here, this is what we're really looking at, is that growth factor.
Ms. Bassett,
Yes.
how would you go from 2 to 1 to 1/4?
Ah, great. 1/2 to the second power.
Ah.
Great question.
Mrs. Bassett,
Yes.
will we eventually get to a point where we do like the inverses, like kind of like what we did for the quadratic?
Absolutely. Yep. So
Okay.
when you think about it, this is just going to take this and that's going to flip it kind of like that.
So
Absolutely.
the exponential growth, the inverse of that is just exponential decay.
No, no, it is not.
Okay.
Nope,
Okay.
that's different. Remember, inverse would be along the line y is equal to x, remember? And so the exponential growth would actually look, it'd be weird. It'd be like a graph like that. We're gonna, yes,
Okay.
we'll be graphing those.
Okay.
Okay, we're almost out of time. Domain, guess what? Same thing, all real. Range. Oh, why did I put a Y? Nobody called me out on that. I put an X, I need a Y. My range, guess what? This is gonna get small. Is it ever gonna cross 0? Nah. So the nice thing about these is you have the exact same domain, exact same range. The big question, of course, is, okay, what's gonna happen once we start moving these? Well, then we'll start changing the domain and range, but you've got this. You know how to do trends and stuff. And so whenever we do that, we'll just go with our trends. We know what to do. We know how to stretch and shrink and flip flop and all that good stuff. So we can do that. Okay.